Hi, so it's really great to be here. I'm really happy to come and talk about this. So I'm going to talk about AI. My area is, like ChatGPT. If I had a lot of blank looks, this could be a really awkward hour. Can we turn the volume down a little bit in the room? Thanks. So I do that, right? That's kind of the thing I do. And it's weird because I used to, go to, I never went to dinner parties. But, I went to, we'll just say dinner parties, and people were like, what do you do? And I explained to them, like, I do AI, and they, of course, don't know what that is. And I'd say, I do natural language processing, and they don't know what that is. And they'd be like, can you have an example? And what I do is like, do you ever use Google to like translate from another language, right? Because like 10, 15 years ago, that was actually, it was like good enough that you could try it. And they'd be like, oh yeah, I do. Do you work on that? And I'd say, well, no, I don't work on that. But I know those people, and like I work on something similar, right? And that's the way I used to like introduce myself about what I did. And now it's like weird because like I walk into Starbucks and the people in front of me online are talking about ChatGPT. I'm like, yeah, I do that. So it's really an exciting time. It's also a time when I think people have a lot of questions about like, what is this? Where did it come from? Is it in my house? These sorts of things. And so what I wanted to do today was talk a little bit about the technology, some of the ways that I see it being used. I'll talk about medicine, which is something I work in a lot. But if we just do like a group therapy session and everyone wants to share their experiences and their questions, like I'm very happy to do that. Right? Because I feel like right now with this technology, group therapy is about the right place to be. Because some people are like, how did you get it to do that? Please explain it to me. I've been doing this with, has everyone seen the new image generation stuff that's out? Right? You can create, you see, it's unbelievable, right? I should have put images in there. I actually have one at the end of the talk, where you can like upload a family picture, and you can say like, turn this into Pixar characters. It's really cool. So everyone's like, how do I do that? Like, how did you do that? Please explain it to me, right? I posted one of these pictures to Facebook and someone asked, who drew that for you? And I was like, oh, I have bad news for you. But at the same time, I think there's a lot of anxiety around these technologies. Exactly what can they do? How are they doing it? What will come next? What will things look like in a year? So I'm happy to take questions at any time and we can just chat about this. Sound good? Going on in society that this is a thing now? Okay. So, but like language models go back decades, and the population knew about them was small. So let me just explain to you the core idea behind the language model, because it's really simple. Here's a sentence: I ate blank. What do you think is in the blank? People shout out some things.
Food, lunch.
Food, lunch. Banana. Bagel, snack. Now, quickly, right? There's a lot of different things that could be there, right? Some things can't be there, like elephant is probably not there, green is not there, right? Okay. If I do this, and I'm gonna add a little more context. For dinner, I ate. What are the things that could be there now? Mashed potatoes, chicken, spaghetti, right? So we narrowed it down. So lunch isn't, I mean, sometimes for dinner I do eat lunch, but lunch is not there, right? A lot of words kind of disappeared, right? I can add more context. As a vegetarian for dinner, I ate a salad, tofu, right? The point is, you hear the word vegetarian, and you're like, okay, well, this has got to be specific to vegetarians. It's probably not popcorn, right? And if I added this context, despite being a vegetarian, for dinner I ate ribs, right? It's incredibly near. And so what's going on here is I'm asking you to do something very, very simple, which is, what do you think the next word is? And what you're doing is you're incorporating more and more context into that decision and narrowing the scope. Fundamentally, this is what language models do. The way we build these models is we give them text in English and other languages, and we say, hide one of the words, look at all the words that came before it, and build a model, learn what word could be in that space, right? And so all it's doing is computing probabilities. If it sees the words for dinner I ate, and then sees the word pizza, it's going to look, it's a little more complicated than this, but fundamentally it will look at all the times on the internet, let's say, that we have the expression for dinner I ate. And it will say, well, how many times was the next word pizza? How many times was the next word elephant? How many times was the next word something else? right? And then we'll get a probability of how likely the word pizza is to be there, right? So that when we say to the model, okay, what do you think the next word should be? It has a probability distribution over all the possible words, and it can fill them in. We've been doing this for decades. This is not new. There are a couple things that are new. Number one, how big the models were to do this. So the models that we use now not just look at for dinner I ate, but they might look at an entire essay up until that point and incorporate all that knowledge into that one word. Okay, that's one thing they're doing differently. The second thing they're doing differently is they're looking at way more text than we ever did. Okay, we used to talk about a couple gigabytes of text, maybe a couple million words. The models now are looking at 20 million words. 20 trillion words. I'm going to drop by a little bit. 20 trillion words. It's hard for me to conceptualize how many 20 trillion is, but like, this is not Wikipedia. This is printing out Wikipedia, putting on a one-sided, piece of paper, really, really small font, and then filling this entire room with bookshelves just with that Wikipedia over and over and over again. It's a massive, massive amount of text, right? Way more words than you would hear in many lifetimes. In order to do that, we need computers, right? You can't build a very big model on lots and lots of text without computers, and so that's been the third secret ingredient, is we've thrown lots and lots of computers at us. When we did that, we kind of discovered something surprising. Let me show you an example. This example is already a couple of years old. I still think of it as being very impressive, but this is old by now. When I found out my grandma was in the hospital, I felt a particular color. When someone cut me off in traffic, I felt a different color. What is the most likely color I would see if I combined these two colors? So, does anyone know the answer? Yeah? Purple? Is everyone good with purple? Okay. So, what we did, not me, this example was from Google from 2022, I think, maybe 2021, I don't remember. They built a giant model, and they gave this to the model, and they said, based on everything you've seen about all the text you've looked at, what is the next most likely word? That's it. What is the next most likely word? Right? And maybe that word is the word the. And they said, great. Given all this and the word the, what is the next most likely word? And keep going until we tell you to stop. This is what it output. The color that I felt when I found out my grandma was in the hospital was likely a sad color like blue. The color I felt when someone cut me off in traffic was likely an angry color like red. So I combine these two colors, I would likely see purple. The answer is purple. Okay. And so what we discovered is that when we're asking a model to predict that next word, just like I asked you to do, and despite being a vegetarian, for dinner I ate, what you were doing is you were using a lot of knowledge you have about the world. What people eat for dinner, right? What vegetarians don't eat, and the fact that the sentence is specifically telling you that it should be something vegetarians normally don't eat that other people would eat for dinner, right? And all of that was going into you saying the word steak or ribs or whatever it was. And it turns out, for the model to effectively capture the next word after a very long sequence, it seems to be learning those types of things. And so now it can produce output like this, where the output is really just asking the model, what is the next most likely word to follow? Here's another one. This is also a real example. Michael is at the, okay, let me see who gets this. Not everyone gets this one. Michael is at that really famous museum in France looking at his most famous painting. However, the artist who made this painting just makes Michael think of his favorite cartoon character from his childhood. What was the country of origin of the thing that the cartoon character usually holds in his hand? Does anyone know? Japan. Japan? Does anyone else have it? Yeah? Italy. Italy? Anyone else? All right, why is it Japan? Yeah, I don't know. Keep going, you're doing great. But keep going, explain.
So originally it would be at the Louvre, and then the most famous painting there is Mona Lisa. The person who created it, I actually forget the name, but I know it's one of the Teenage Mutant Ninja Turtles. And
yeah.
And so I.
It's Leonardo.
Thank you. think it's purple. I'm pretty sure he holds like whatever the blade is.
A katana.
Thank you.
Yeah. And that's from Japan, right? You said Italy? Who said Italy? Why? That's also the next most common answer.
I just assumed pizza.
Right, okay. You assumed pizza. Right? So this is the answer. So, and it's mostly what you said, except this is wrong. It gets Japan as the right answer, but Leonardo da Vinci doesn't normally hold a katana. It's the turtle, right? But it still gets the right answer, right? So this is to me really impressive. And this is the core of the technology, is just what's the next word. We've added a lot of tricks to it, and we've made it better, and there's a lot more to say that I'm not going to go into because of time, but the core of the technology is just what is the next word, I should say.
You know they use AI now.
Yeah.
You really need to use the buzzwords, you need to use this, because that's how they sort your resume. So it's being used in the job world.
Yes.
I don't know about
Oh, for
here.
sure.
Yes, because right now the market's being flooded because 10,000 people left my particular site. And they give you little workshops and all, but we were instructed that was critical.
Yeah, so I say for jobs and hiring, many companies are using this. Go ahead and Google for companies that are selling these technologies. You can see what they're selling. I would say that I find a lot of the work questionable. Doesn't mean people aren't doing it. There's also software that will interview people for you and then write a summary of the interview and send it back to you. I don't particularly like that as a way of doing things. I like to think universities are a little bit more responsible with admissions. But yeah, outside of the university admissions world, 100% companies are doing this. And it's, I think a lot of that is problematic. So we get way more, I mean, you can look at the statistics online. Actually, Hopkins posts all statistics, but I think computer science, I think it's like 5% acceptance rate, something like that for a PhD. Maybe it's a little bit lower now, 2%, I don't remember. That's incredibly competitive, right? And that also means we're getting a lot of applications. If you can find an application that looks great, right, it makes your job easy. Right? So what does looks great mean on a PhD application? They have letters from well-known people that say great things. They have a bunch of papers, right? Their research statement says all the right things that shows they know a lot about the field. They have great grades. It's not that hard to find those quickly, and so people latch onto those, and given that there's a finite number of those types of applications, they get all the invites, they get all the interviews and such, right? Where I think AI can help is that there's a large number of people who I think are of that caliber, but don't have applications that look like that, right? So why don't they? So let's say you went to a small liberal arts college, right? It doesn't mean you're not as smart, right? It doesn't mean you're not as talented, but it means that you are unlikely to work with one of the leading researchers in the field. Right? And so you don't have that letter. It means that you're unlikely to have taken a class or received instruction that gave you the ability to write that research statement that shows that you know all this stuff. Right? It means that you are unlikely to spend the year in a research lab that was, NIH funded or NSF funded that got you a paper. Okay? So when you go to look at that application, it's missing all of those things. That means it's much harder to evaluate those people. This is actually where I think AI can help. Because harder also means it takes more time. You have to read it more carefully, right? You can't just say, oh, I know the letter writer, let me skim it, oh, this is great. You have to read the letters really carefully, right? AI has that kind of time. And so I think where AI can help is not, rank everyone for me, but pull information out of these applications that might be hard for me to find, that gives me a more holistic view of the applicant and allows me to better judge the quality of this person, right? So anyway, I think this is where there's opportunities. I have some projects, not for admissions, but for other types of applications looking exactly at this sort of thing. But I think that a lot of people look to AI as how do we replace what we're doing? And I think where the bigger opportunities and more interesting opportunities is how do we make what we're doing better? Right? How do we find things that we're not doing well, where people struggle? AI can help people do a better job.